So we subtract 1 from both sides, or 1x squared, we get 0 over here, with cancellation. And notice what happens here. The x squareds also cancel out because I have just as many on this side as I do on this side. So subtracting away x squared from x squared gives me 0. And then I'm just left with 4x plus 1. Well, that's just reduced now to a simple linear equation. So now I have a linear equals a constant. And I just need to isolate x. So I can subtract my 1. And I can do this again because the x squareds have disappeared. And now I divide by 4. And I would get x is equal to negative 1/4, which is negative 1/4, or 0.25. So right there, that's negative 0.25, and that's where they intersect. And now I could plug in that value into either equation and figure out exactly what output value that corresponds to. Let's take a look at one more. Now we have a rational equals a constant. So I have a linear divided by a quadratic equals a constant number. Just remember, a polynomial divided by another polynomial is considered a rational function. So the first thing we've always done is we've cleared the denominator on both sides. So I've multiplied through by 2x squared plus 12 and 2x squared plus 12. Now remember, again, this is the same idea as if I have 6 divided by 3 equals 2. This means that if 6 divided by 3 equals 2, that 2 times 3 equals 6. So that's really all we're doing here. We're saying if 5x plus 10 divided by this equals this, then this times this must equal the numerator. So 5x plus 10 equals, and now if I distribute, I would get 1x squared plus half of 12 is 6. And now I have a quadratic, so I am going to have to isolate all of my terms to one side. And I will do that by subtracting 5x first. And you can subtract 10 first if you want, but you get x squared minus 5x plus 6. And then I subtract 10 to get 0 on the left-hand side, and I get 0 equals x squared minus 5x minus 4. So now I can notice that a is 1, b is negative 5, c is negative 4. And I'd put it into my quadratic function, and I would get that x is about negative 0.70, or x is about 5.7. So those are the two solutions I would get. Now yes, we're actually solving a quadratic equation here. We're looking at for when does the parabola x squared minus 5x minus 4 equal the constant value of 0. But that was the same thing as addressing when does this rational function equal 0.5. So now I know when this rational function will equal that particular constant. Let's take a look at an applied situation. So the interest rate for a 30-year mortgage, y, is modeled as a function of years after 2006, x, by the equation y equals negative 0.424x plus 6.716. Now this is a linear function, and that interest rates for a 15-year mortgage are y equals negative 0.05x squared minus 0.2x plus 6.121. Will the two rates ever be the same? If so, which offers a lower rate after that time when they are exactly the same? So let's just think about sketching them first. So the first one would look like this. It would start at 6.716 and drops by, or at a rate of negative 0.424 per year. And this is years after 2006 and the rate. Well, this one starts at 6.121. The initial rate of change is negative 0.2, which is a little bit slower than the drop in this one. But then that drop is increasing, so eventually it'll start to come down. And it'll come down faster and faster. Now the question is, will they ever touch? Or will this one just drop faster than this one will? Well, let's see. So we want to know, when does this y equal this y? So the y's will be equal when the right sides are equal. And when that equals negative 0.05x squared minus 0.2x plus 6.121. Okay, so now we would set them equal to each other, or isolate the terms. So I would add 0.424x to both sides, add 0.424x, and I would get 6.716 on the left, negative 0.05x squared. 0.424 minus 0.2 would be plus 0.224, and then I still have the plus 6.121 over here. Now I would subtract 6.716, and I would be left with negative 6.716. I'm going to write it up here. 0 equals negative 0.05x squared plus 0.224x, sorry, I forgot an x down here, minus negative 0.595.